Very similar process to the previous proof for the first law. When you are taking away, okay, two logarithms with the same base, so you've got log x, you take away log y, we can write it as a single logarithm, okay, but you actually divide the terms, okay, and we'll show now why that's the case, why that works like that, okay. Again, it'll be relying on our understanding of indices. So, just like before, okay, I'm going to define log to the base a of x to equal to something, because it is equal to something. So I'm going to say, look, let log to the base a of x equal to m. Okay, I'm going to use the same letter again, and log to the base a of y equal to n. Okay, and just as we've seen before with our understanding of logarithms, okay, I can get rid of the logarithm here, can't I? Okay, I can sort of unlog it. I can get rid of it by changing this equation here. So I take that base over the other side. I'm left with x, and then this base to that power, isn't it, m? Okay, because that's what the logarithm is equal to, isn't it? Is a power. So do the same here. Get rid of the logs, take the base over. So I got y left here, then a to the power n. Okay, well, let's look at the results that we've got here. Okay. Well, what are you doing? Well, you're dividing, aren't you? X divided by y. Okay, so I can write that there and replace x and y with what I've got them to be. So I've got a to the power m there for x and a to the power n there for y. Okay, and then it's going back to your understanding of indices, and you realize, of course, we are dividing here. So when you're dividing, okay, when you're dividing terms with the same base, think of the rule we can use for indices. Well, of course, we take away the powers, don't we? So I can write this as a to the power m minus n. Okay, you subtract the powers, and again, you know, I can write down here why I've done that, because of the rules of indices. And then just think what I've got here. Well, I've got xy equals to a to the power m minus n. Now, suppose I want to work out that power. Well, I'd use a logarithm, wouldn't I? I'd take that base over the other side, and it would create a logarithm. So it would be logarithm to the base a of x over y, and that will equal then to this power m minus n. And then you go back to your definition of m and n, and you just substitute them back in, and you get the required result. So it's log to the base a of x minus log to the base a of y.